All right, today we're learning section 10.4 polygons. All right, so terms you need to know. Quadrilateral, okay, and these terms are on page 494. So you need to write in your notes, know the terms on page 494. A quadrilateral is a geometric figure made up of how many line segments? Four, which means that there are four sides to a quadrilateral that only intersect at their endpoints. A polygon is a geometric figure. What is that a fancy term for? Shape. Okay? It's a shape that is made up of three or more line segments that only intersect at their endpoints. Another important part of a polygon is that it's a closed figure. It is not open. All of the line segments connect to each other. And then you have a regular polygon, and this is a polygon with all sides and angles equal in measure. All right, so that would be a regular polygon. All right, so those are some of the terms. Again, all three of those terms are in section 10.4, and you need to make sure that you know them. All right, now let's talk about special quadrilaterals. We have a trapezoid. A trapezoid is a quadrilateral that has one pair of parallel sides. Okay, so you'll see that indicated by arrows. Again, this is right here in your notes on page 494, so just make sure that you are familiar with these charts and that you can identify these figures. You don't have to draw them in your notes. A parallelogram has two pairs of parallel sides. So in order to tell the difference, one of the pairs will have two arrows and the other pair will have one arrow, and that's how you'll be able to tell which ones match each other. Okay? All right, so that's a parallelogram. Again, all of these have four sides. So we have a trapezoid, a parallelogram, and then we have a rectangle. Now, a rectangle has four what? Four right angles. And it has two sets of equivalent sides. All right, so my width is going to be the same on both sides, and my length will be the same on both sides. And I indicate sides that are equal in measure by using the dashes through the side to match them up. Do you see that? So I have one dash through the width, and I have two dashes through the length to show that they're equivalent. Now, a square is another parallelogram, meaning that it has four sides, and both of them are parallel, both pairs. But now, all four sides are congruent. They're all congruent, and you have four right angles. Instead of having the lengths be congruent and the widths be congruent, a square has all sides congruent. And then last but not least, you have a rhombus. This is all congruent sides, except you don't have right angles. All right, so you need to know the difference between your different quadrilaterals, your rectangle, square, rhombus, trapezoid, and parallelogram. All right, so again, in your notes, you should say know the terms on page 494 and 495, and there's one term on page 496. All right, so now we're into example 1. Here we have the instructions to draw a figure, okay, but we don't necessarily know what type of figure it is, so we use the clues to figure it out. It says it's a quadrilateral, so how many sides is it going to have?
4.
It's going to have 4 sides. All right, now, are all the side lengths the same? No. Now, it says opposite sides are parallel, so that's important. One side has a length of 3 centimeters, and another side has a length of 1 centimeter. So I know I have sides that are different lengths. One is going to be longer. Now, does it say anything about right angles? No. So this figure that I'm drawing does not need to have right angles. All right? Okay, so now I know that I have a couple equivalent sides, 3 centimeters. And then my sides and my width are 1 centimeter. So now I can classify this quadrilateral. What type of quadrilateral do I have?
Trapezoid.
That is not a trapezoid. Their opposite sides are parallel. I have two pairs of parallel sides. What is it? What type of quadrilateral? Nope, not a rhombus. It's a parallelogram. It's not a rhombus because all of the sides are not congruent. So this is a parallelogram. All right, so sketching the figure and then classifying it. You need to be able to do that. It's a parallelogram. All right, now I want you to try one. Okay, sketch and classify a quadrilateral with 4 right angles, 4 congruent sides of 2.5 centimeters, and both pairs of opposite sides parallel. Go ahead and sketch it. All right, so let's sketch this out and see if your answer matches mine. I hear it. All right, well, if you have right angles and if all the sides are 2.5 centimeters, what type of figure do you have? It's a square. It's a square. 2.5 centimeters. All right, so I do have a square. All right, so now example 2. Shh, quiet please. In example 2, we're classifying polygons. Now, this is not the only shape that one of these polygons can be, okay? These are more or less the regular polygons and what you would see as a regular pentagon and hexagon. But remember, any type of closed figure that has line segments, you count the sides, and then that's the type of figure it is. So, and again, you don't have to copy these down. It's right there in your chart on page 495. You have a triangle that has 3 sides, a quadrilateral with 4 sides, a pentagon with 5 sides, a hexagon with 6 sides, a heptagon with 7 sides, and an octagon with 8 sides. All right, so a polygon is a closed figure, has line segments that meet at their endpoints, they don't cross, and that's a polygon, okay? No curved sides. So based on that, let's figure out which ones of these are polygons. Top left, is that a polygon? Or, yes or no? No. Why not? Because it has a curved side, and polygons don't have curves. What about the arrow? Is that one?
Yes.
Yes, it is. Yes, it is. What type of polygon is it? How many sides does it have?
2, 5, 6, 7.
7, so it's a heptagon. Very good. What about bottom left, diamond?
No.
Of course it is.
Oh, never mind.
It's a polygon. And what type of polygon? Quadrilateral. More specifically, what type of quadrilateral? It is a rhombus. Now, you wouldn't necessarily know that without knowing that the sides are congruent, but it does look like all the sides are congruent. All right, what about the bottom middle one? No, because of because the little curved sides can't have curves. And then what about the bottom right? Yes, and what type? It's 1, 2, 3, 4, 5. It's a pentagon. It's a pentagon. All right, so example 2 deals with classifying the polygons, telling whether or not it's a polygon, and then what type. Now, example 3 talks about a regular polygon. Do you remember what I said about a regular polygon? And I have the definition here. What is it? All what?
All sides or angles are equal.
All right, they are all equal. They're all equal. And this is what you'll see if it truly is regular. You'll see a dash, and it will only be 1 because it'll show that all of them are equal through the sides. That shows you that all of the sides are equal. And then you'll see a little curved line in each of the angles to show that each of the angles are equal. Now, with your polygons, if it is a regular quadrilateral, the sum of the interior angles is always going to be 360. If it's a regular pentagon, sum of interior angles will always be 540. So there's a pattern to it. You know what the sum of the angles will be if it's regular. All right, so here in the example it says find the perimeter and sum of the angle measures. Well, if it's regular, if it's regular and you know that one of the sides is 3 feet, how can you find the perimeter? How can you find the perimeter? Hazen?
Equals. If it's a polygon, all of them are 3 times the length times
Yep.
times the width.
You just multiply the length of one of the sides times how many sides you have, and you get 15. You get 15 feet, and that would be your perimeter. And then with a pentagon, the sum of the angle measures in a pentagon, I know is 540, and that's something that we'll memorize as we get into our lesson tomorrow. But generally, that's everything you need to know for 10.4.